Hello and welcome to Slooh. A little bit late, but we're here. The Blue Moon Gremlins were giving us a bit of a fight this evening, but we're here. So anyway, welcome to Slooh, where you can learn to explore space as part of a worldwide community of members. Now, I'm Paul Cox, and you're joining Slooh for a very special lunar event tonight. Plus, we'll be talking about the other big news story of the weekend. That old bit of Chinese space junk, not space junk, but actually it's their heavenly palace, Chong-1, is going to be ripped apart in a fiery end sometime over the next 24 hours. And we'll be telling you how to find out if and how you'll be able to see it from wherever you live at the end of the show. So don't miss that. But tonight, our real focus is the moon, and we're going to be watching live streams from Slooh's telescopes of a rare blue moon, the second full moon to occur in a single calendar month. Now, the last blue moon was that utterly amazing blue super wolf moon total lunar eclipse on January the 31st, if you joined us for that one. But not only that, but this March full moon is there's that eclipse moon. Look at that. Wasn't that fabulous? Blue super wolf total lunar eclipse moon. I still trip up about that. Anyway, but not only that, this particular March full moon is also what Native Americans named the full sap moon. And we're going to be hearing why that was a little bit later as well. But if all of that wasn't special enough, this is the last time two blue moons will occur in the same year, which is called a double blue moon. Okay, you didn't need to be a scientist to know that, until 2037. So there's the calendar, that's the lunar calendar for this month, and you can see that first full moon was on the 2nd of March, and then today is on the 31st. Actually, slightly earlier today was the actual moment, but we've got some great feeds. But anyway, listen, before we take a look at what we've got coming up in the show and our very special live feeds that we've got, we want to ask you to support Slooh. Now, if you're here, you're probably interested in learning about space or astronomy. And if you are, please consider joining Slooh as an apprentice or astronomer member to support our mission to teach the world to explore space. And you get to watch live views of the sun, the moon, the planets, galaxies, nebulae, star clusters, constellations, supernovae. I think I've got them all, but just about every single type of celestial object in the night sky through Slooh's online robotic telescopes that you get to control from the comfort of your own armchair as a member of Slooh. So actually take a look at, if you want to see the benefits of membership, take a look at these remarkable posters that were created by two members during our 2018 Messier Marathon a couple of weeks ago. They're coming up on the screen in a sec. When we watched, as members from around the world, we were watching this live telescope feeds of all 110 of the best and brightest objects. There they are in the night sky in a single night. I mean, members from around the world were there for 10 hours. We were on air for 10 hours, and people have created these brilliant posters of all of these best celestial objects in the night sky. Oh, I've been with Slooh for 14 years, and I think that was my very favorite event over 14 years. So well done to everybody there. But you can see those objects every single night live through Slooh's telescopes. Now, as a member, you can also follow our various courses and live casts about astronomy too. So join Slooh's global community today, where we're all kind of learning to explore space together. Now, back to our event tonight. What have we got coming up in our Blue Sap full moon show this evening? We'll be learning about why this blue sap full moon is so special and what makes it a blue moon to start off with. I'll be joined by Slooh's lead astronomer, Dr. Paige Godfrey, as we watch the first images streaming in from Slooh's Canary Islands Observatory from the telescope. That's going to be in 5 minutes' time. Now, Paige will then be teaching us some lunar science, some fascinating facts about our nearest celestial neighbor. And after that, We'll be joined by Slooh's storyteller supreme, Helen Avery. Now, Helen will be sharing some moon lore and why full moons were given so many different names in different cultures down the ages. And make sure you hang around until the end of the show when we'll be telling you how to watch that bus-sized Chinese space station Tiangong 1 as it burns up in its fiery end sometime over the next 24 hours or so. So we've got the very latest forecast for you there. Now, we also want to hear from you. So if you want to ask me or our guest questions, just use @Slooh on our Facebook or Twitter channels. And members can also post questions to the Slooh discussion boards as well. And don't forget, if you're watching in the Situation Room at slooh.com, you can switch between our live feeds and snap and share your own pictures from those live feeds coming up. Now, talking of feeds, what do we got lined up for you tonight? Well, we'll stick on this image for a short while because I'll tell you about that in a sec. But we're using the telescopes and the special cameras at Slooh's flagship observatory at the Institute of Astrophysics of the Canary Islands. Now, that's home to the world's largest optical telescope and home to the telescopes that Slooh members get to control every night. And there you can see this wonderful panorama. This is a live panorama view of that observatory. You can see the enormous professional domes there, but it kind of looks like daylight, doesn't it? Kind of blue sky, looks like the sun over there in the top left. Well, it's not. That is our full blue sap moon rising. And we've got a great dome cam of it as well coming up. But let's take a look at some of the feeds. Let's take a look at our Pico del Teide cam, if we've got that available. Now, this is a shot that's looking down from 10,000 feet down to the observatory, which is at 8,000 feet high. We might have that coming up a little bit, but we might have the dome cam as well. So I know the studio having a few little problems, so I'll just talk about whatever views that we've got coming up. But we are also going to be using 3 of Slooh's telescopes. They come online at 20 past the hour. That's in 3 minutes time. Now, the first telescope that we've got a live feed of this blue moon from will knock your socks off. It's our flagship instrument. It's the mighty half-meter telescope. It's going to give us unrivaled high-resolution views of this blue moon this evening. And we've also got our Canary 2 ultra-wide field telescope, and that's going to give us a live image stream of the entire disk of the full moon. But we've also got some great close-ups. You see that live image just changed. That's quite cool, isn't it? We'll also be using the Canary 4 solar system telescope for some absolutely great close-up views of the moon. Now, the moon is only a few degrees above the horizon at the moment, so the image is not going to be absolutely perfect, but it's still going to be pretty cool, I think. So sit back, enjoy the live views, and enjoy this very special event with the rest of Slooh's worldwide community to learn to explore space. And don't forget, watch over at slooh.com in what we call the Situation Room, where you'll be able to snap your own pictures from the live streams as they come online. Now, I'm going to just tell the studio that the studio, because we're running a little bit late, we will catch up with ourselves, but they can bring Dr. Paige Godfrey, Slooh's lead astronomer, into the show at any time to join me as we hop over to our live views. But in the meantime, I'm going to carry on. And so that's what we're kind of coming up and what we're going to see so far tonight. But what is the blue moon? Is it blue? How frequently do they occur? Is this blue moon more special than any other? Well, we enjoyed 2 full moons in January, no full moons in February, which is really rare in itself. And tonight we're welcoming in the second full moon of March. Now, the first one of those was on March 2nd. So this double blue moon, 2 blue moons in a year, is exceedingly rare. Hello, Paige. Welcome to
Hi,
the
Paul.
show.
How
Now,
are
listen,
you?
I'm very well. I'm very well. The studio have done a brilliant job. Laura Grosso in the studio is doing a brilliant job to kind of get us back online. And we've got these live telescope views, Paige, which are going to be starting any time now. So the studio kind of let us know. But really, what I was going to go through now was really just to explain what a full or a blue moon was. And
Mhm.
you know, Paige, feel free to butt in at any point here and shout if you see one of the live images coming on the screen before I do. But so what is this blue moon? Well, the commonly used definition of a blue moon is simply the second full moon to occur in a calendar month. But you know, that definition is actually relatively new and was born out actually of this misunderstanding of the older seasonal definition by an author of a magazine article in 1946. And its adoption, that new definition, its adoption as the definition for a blue moon kind of gathered pace after it was repeated in, I think it was an NPR radio program called Stardate, and that was in kind of 1980. And then it even appeared as a question and totally cemented itself into modern culture in 1986 when it appeared in a Trivial Pursuit as a question. Paige, I don't think you were even born in 1986, were you?
No, Paul, I was not.
No. No, that's a compliment. That's a compliment from an old man. That's a compliment. So, but you know, I
Well,
don't
thanks.
know about you, Paige, but you know, hearing that original seasonal blue moon definition, it was actually the third full moon in an astronomical season that contained four full moons. Now, I don't know about you, but the modern definition is far easier, isn't it, to understand than that one?
Yeah, I had no idea that it was a recent term.
Oh, right. Okay. So, yeah, a very
Yeah,
recent cultural thing. And we're
I had
still
no
not
idea.
entirely sure where even the original one came from. This, oh, what have we got there? Oh, that's the dome cam coming in now. This page is,
Mm.
you'll know this, but we've actually pointed, this is our dome cam, which we normally, oh no, sorry, it's the Pico del Tedi cam. So this is the one that is right high up on this volcano, this volcanic peak, 10,000 feet up. And actually, below the full moon, you can kind of see their Paige. That's the reflection of the full moon in the Atlantic Ocean. And
Yes.
just further down from there, we can't quite see it. Sometimes we can see a light on there for cars driving, but 2,000 feet below this camera is Observatorio del Teide, which is where the Slooh telescopes are based. So we'll comment on any of the image streams as they come live. But if you are watching at
They
slooh.com in
are
the situation,
live.
are they? Oh,
I
oh,
don't want
oh.
to
So
interrupt, but yes.
no, absolutely interrupt. We always interrupt for live images coming in. So studio will bring those in because I'm really excited because we don't usually use our half-meter telescope for the moon because the half-meter telescope is kind of too sensitive almost. So we have to do some special trickery and magic stuff behind the scenes to make that work. But that's going to be the view page that I'm really hopeful for tonight. But while
It's
we're waiting for that,
gorgeous.
then, is it? Is it? Oh, you
My
can already see
eyes
it. Oh,
probably
I want
keep
to see it.
darting from the screen because I'm looking on my split monitor at the actual telescope feeds on Slooh.com, and it's unreal.
Okay, so again, it's the half-meter telescope, Canary One. So that's going to be coming into the show any minute now. But hop over to slooh.com because if you are watching that, you can flick on these little tabs below the video,
Hmm.
and you can actually press the camera button, and you can snap and share your own images from those live feeds. But I'm going to just go back very quickly now to how often blue moons occur. Now, Paige, the moon's period of phases, it's lunation. What's that? 29.5 or something like that
Yeah.
days long. Yeah.
Hmm.
And we know, of course, that most months, I mean, I'm dreadful at a calendar. I cannot tell you which months of the year have 30 or 31 days in, but we know that most months, other than February, have 30 or 31. So, come on, Paige. We're all bad at some things, and one of mine is always knowing that. So, but if a full moon occurs on the first day of the month, with the exception of February, then we'll also see a full moon at the end of the month. And this happens
Hmm.
every 30 months on average. And in this case,
Oh,
we're going to have to wait until it was October 31st, 2020 for the next blue moon, just a normal blue moon, using that twice in a month definition. So no doubt there's going to be lots made. In fact, we'll probably make lots of it that's a blue moon occurring on All Hallows Eve. But this double blue moon, two blue moons occurring in a single year, is what makes today's event even rarer. So rare that it actually only happens 3 to 5 times in every century, Now, the last time
Hmm.
this happened, two blue moons in a single year, that was in 1991. And we're going to be waiting until 2037 for the next time a year has two blue moons in it. So, and of course, the result of that is that February doesn't have a full moon, just like last month. So, that's oh, look at that! Oh, that's coming in. So there's the Canary 1.5 meter telescope view coming
Yay.
in. Wow, look at that! And depending page, we do the supermoon shows and the mini moon shows when the
Hmm.
moons are apogee or perigee, when it gets bigger and smaller. This telescope is so tightly fixed to the size of the moon, its field of view, that we know that the moon at the moment is quite far away, because when the moon is closer to Earth in its elliptical orbit, it actually doesn't fit quite in
Mm.
that entire image. But so what do you make of this page? What are we actually looking at here? This is the full moon, obviously, but we're looking at the Canary 1.5 meter telescope. What are all the blotches
Hmm.
on there and stuff like that?
Lunar surface features. So the dark features are actually deep cratered regions that have been filled in with lava.
Okay,
And when the lava cooled, all of the iron had it cool and harden into this dark color. And so then the
okay,
bright regions are called the lunar highlands. And because they're higher up in altitude, they weren't able to be covered by the lava. So the dark
okay.
regions are called the lunar mare, which because back when they were first observed, they looked like seas, which we know they're not filled with water, but they're filled with lava, which is I think equally as cool.
It is, absolutely. And, I've always, whenever I think of them as being Mare seas, I always think of those early astronomers and thinking how dreadful their telescopes actually must have been for them to think that they could have been filled with water, and what was it? It's Galileo Galilei who's the first guy
Hmm.
to kind of point his telescope and start sketching out some of these features. And he presumably was one of the first people to realize that they weren't seas or jungles or trees or any vegetation or anything like that. So,
You can
yeah.
see a
Uh,
nice close up on
okay.
the Canary 4
Oh,
of
right.
the a dark region, a dark mare region. So if you hop over on our website, you can take an image of a more zoomed in region and you can really see where like kind of the craters are lit around by the bright areas that are higher altitude.
So,
So
Paige, you're going
cool.
to tell us. Oh, look, that's our ultra wide field telescope. So this is the Canary 2 ultra wide field, and this is a
Oh,
perfect telescope. It's got a huge field of view on it, which means that we not only get the moon, but we get a lot of surrounding sky as well, and that's always an impressive sight. So, uh, when
Paul,
you're
can you
doing
tell
your
our
bit,
users
yeah.
how to get to the ultra wide field?
What do you mean on the
Hmm.
during the show in the situation room? So in the
Yep,
situation
on the
room
website.
on the website, uh,
Yeah.
you mean the live telescope views or the
Hmm.
situation room? Right.
The
So
live
if you
telescope
just
views.
the live telescope view. So whenever you see in the left-hand navigation, whenever you see that telescope button turn green, you know the telescopes are online. Now, if you'd been there today, hopefully you saw this page, but it was green during the day, and some people
Hmm.
might have been scratching their head. Well, how can the telescopes be online during the day? Well, we had our solar telescope online, Canary 5 online today, and we were watching these enormous solar prominences of the edge of the moon. But if you want to get to the telescope page for this particular telescope, then go to telescopes, go to Canary 2, and then on that particular telescope page, the Canary 2 telescope page, you'll see two tabs. One of them says wide field, and the wide field doesn't take any images of the moon. But if you click on the one that says Canary 2 ultra wide field, then that's the one that you're going to get this absolutely fabulous view on. So yeah,
Got it.
but if you're watching in the situation room, I think we've got those set up as tabs down the bottom. Anyway, Paige, I got one little thing to cover before you're going to tell us some of uh,
Mhm.
Dr. Godfrey's fascinating facts about the moon. And we were asked a question last week: is the blue moon blue? And that really is
Ah,
kind of the biggest question of all, isn't it? Does the
yep.
moon ever look blue? And unfortunately, not, as we can see by our live images tonight. But I was doing some research about this, there are some atmospheric phenomena that can turn the moon blue. Now, I've never seen this, but I'm intrigued to do
Mhm.
so, so I'm going to hunt this down. And one of the most common causes is smog. So our Victorian ancestors over 100 years ago maybe saw quite a few blue tinged moons quite often. But I was thinking about this today. Unless you're living in China, it's unlikely you're going to be coming across much smog nowadays. But we have seen rare examples of the moon taking on a bluish tinge, and I put together a little example of this, of what it might look like, so the studio might be able to bring that in. But we've seen examples of this bluish tinge following volcanic eruptions and forest fires. So wouldn't it be great, Paige, if that's what we could really
Wow.
see with a
Yeah.
blue moon? I just couldn't resist doing it. All right. So, and thankfully the studio have put on there, it is a simulation. But it's about, it's this can happen, not quite as acute as this, during volcanic eruptions or forest fires. If the ash particles are exactly the right size to scatter red wavelengths of light,
Mhm.
more than the blue and green, um, but they have to be, I think, almost down to a single micron in size. But
Mhm.
I would certainly, I'm going to add this to my astronomy bucket list page, to witness a blue moon, but not a blue moon like we're seeing tonight. So that's
Right.
probably a good time, isn't it, for me to exit and leave it over to you for some of your fascinating science and stuff about the moon. Yeah.
Awesome. That
I'll see
actually
you
makes
later,
me
Paige.
think. All right,
Go
sounds
on.
good, Paul.
Okay.
There was a strawberry moon that happens in June. It's just one of the names of the moons, and Helen Avery will talk about this a little bit later. But strawberry moon, which is named for the harvest of the strawberry season, when that moon occurs, it's not red, it's not a strawberry color. And last June, somebody asked me that question, and I was like, no, of course, it wouldn't be red. Turns out that one year there was a strawberry moon that was a little bit pink. And this is exactly what Paul's talking about. So the moonlight is actually reflected sunlight. The moon does not shine its own visible light, it's a rocky body. And so the sunlight shines onto the moon and gets reflected by the surface of the moon. And that's the light that we're seeing. So when we look at the moon, we see this white light because that's what the sun appears to us because of its temperature. It's kind of all of the colors of the electromagnetic spectrum in the visible range. And so it appears like white light. Now, when the light is reflected into our atmosphere, it gets scattered off of our atmosphere particles. And so when you see a blue sky, that has to do with the atmospheric scattering. When you see a red sunset, same concept. So it depending on how much atmosphere the light is going through and what kind of atmosphere the light is going through is how much light is going to be scattered and at what wavelengths the light going to be scattered. And so sometimes we could see a blue tinted moon or a red tinted moon in the same way that we see a red sunset. And so this kind of brings me into the first thing I was going to talk about was lunar phases and why we even have a full moon to begin with. So the moon orbits the Earth every 29 and a half days, like Paul mentioned. Now, the sun is shining on the Earth moon system. This is a great graphic of the lunar phase calendar. And so you can see how on the 2nd of March, we had a full moon. And about 29 days later, we have another full moon. So when the Earth is shining on the Earth moon system, when no, when the sun is shining on the Earth moon system, the sun is illuminating the part of the moon that is facing it. And depending on where the moon is in the orbit around the Earth, we see part of the illuminated moon. So there's really great examples online. If you just Google like moon phases and go to like Google Images, you can see kind of some simulations of how this works. But if the sun is over here, you can't see that arm. There we go. Now you can see that arm. If the sun is over here and the Earth and moon are over here, the sun is shining its light onto the moon. And depending on where the moon is in the orbit around the Earth, you're going to see portions of the illuminated half of the moon. Now, we only ever see one face of the moon. That is because the moon is tidally locked to the Earth. So, what that means is that the moon is orbiting about itself in roughly the same amount of time that it takes for the moon to orbit the Earth. And so, this means the same face of the moon is always facing Earth. But the other side of the moon, the far side of the moon, which is sometimes called the dark side, and I don't like that term because that implies that it doesn't get any sunlight, which is not true. It does get sunlight shined on it. It's just that we don't see it. But it was seen for the first time in 1959 by the Soviet Luna 3 spacecraft when they went around the back of the moon and returned images. And since then, there have been several NASA missions that went around the back of the moon. So we have seen it, we have seen images of it. Now, the moon, in its orbit around Earth, it's not perfectly circular. So it's an elliptical orbit. And so the moon is about 384,000 kilometers from Earth, which is about 240,000 miles. Roughly 30 Earths could fit between us and the moon. But this is an average distance because the moon distance varies by about 13,000 miles in either direction based on its orbit. And actually, the moon is also moving about an inch per year away from the Earth. So its orbit is not particularly stable. It is one of the largest moons in the solar system. It's the fifth largest moon, but it is the largest moon in the solar system in relation to its host planet. Now, Mercury and Venus don't even have moons. The rest of the planets do, including dwarf planet Pluto. But ours is the largest in relation to the planet, and ours is actually, well, because Pluto's a dwarf planet, so it's not included in this. But our moon is actually rather large. And the moon and the Earth have similar compositions, but they're not perfectly similar. There is a lack of iron and an extreme lack of water on the moon. So this kind of ties into the formation theories that astronomers think could have formed the moon. And there's three major ones. The first one is that some sort of planet-sized body, maybe a Mars-sized body, crashed into Earth in the early solar system formation and broke off a big chunk, which became our moon. The second idea is that there were, instead of one large crash, there were many small crashes that broke off little pieces of the Earth that then gravitationally coalesced together to form the moon. And then the third idea is called the capture theory, where there was a rocky body that was passing by Earth, maybe on its way towards the sun, being kicked out of the outer solar system orbit, by maybe Jupiter's immense gravity. And then we kind of stole it because our gravity overtook its trajectory towards the sun. So initially, back in the very early solar system, when the Earth was just forming and the moon was just forming around the Earth, it spun much faster. But because it's not perfectly spherical, it has a bulge around the equator, it slowed its orbit down, which is why it's now tidally locked. The orbit of the moon around the Earth is what's keeping Earth's orbit and wobble stable as well. Actually, in the very early solar system, our day was only 10 hours long, not 24 hours long. But because the moon has gravity and it's pulling on the Earth, we have ocean tides as a consequence of this. That sort of friction slowed down Earth's rotation, giving us our 24-hour day. This is a lot. I'm going to give you one last fact before I call in our storyteller, Helen Avery. But I really love this one. The brightness of the moon. We kind of notice this when we look at the sun too, and Paul Cox is going to talk about this a little bit later, the apparent size of objects in our sky. But how about the apparent brightness of objects in our sky? The brightness of any object, including the moon, increases with its height in the sky. So when an object is directly overhead, its light is striking the ground at a right angle, at a 90-degree angle. So the intensity of this light beam, the intensity of light is the same as the intensity of the beam. When an object is nearer to the horizon, and the light is shining at an angle that's not 90 degrees, its light is striking the ground at an angle, and the same amount of light that was coming this way and is now coming in this way is spread out over a larger area on the Earth. Less light per unit area reaches the ground. So, also, the closer that the moon is to the horizon, the more atmosphere that the light has to go through. It's the same angle issue. So, not only is less light per unit area hitting the surface, but it's going through more atmosphere to get to the surface, and more light is scattered away. So, it'll be less bright when it's closer to the horizon. Oh, look at that. This is our Canary Islands Observatory. You can see the moon rising in the sky. And now that was, I think, enough lunar facts. I think I just threw a bunch of you all at once, but I hope they made sense. But we are going to call on our constellation storyteller, Helen Avery, to tell us about some moon lore and about the term blue moon, the term sap moon, the lunar calendar, and how it's affected our culture. So let's bring Helen Avery on when the studio's ready. Oh, there she is.
Hi,
Hello,
Paige.
Helen.
Hi.
It's great to share this with you, and you have the perfect background for this show.
I know, right?
There you
That.
go. And your earrings. I'm wearing my moon necklace.
Yeah, I saw her. Yay for moon jewelry.
Got to dress the part.
Right.
All right,
So you
Helen.
just
Well,
blew
do you
my
want
mind
to
with
tell
those
us?
facts, Paige. Huh?
Thank you. I said, do you want to get started telling us about the term blue moon?
Yeah. So I mean, I know Paul talked about it at the beginning, but if you missed it, the term blue moon is sadly not because the moon is blue, as you said. But and actually, I can't even find where it came from because I know that Paul mentioned it used to refer to if you had four full moons in one season. Um, and where this was referred to was a place called the Old Farmer's Almanac, and we're going to talk about the Old Farmer's Almanac in a bit because it's this wonderful source of moon names as well. But the Old Farmer's Almanac was set up in like the late 1700s, and it was like a publication that spoke to rural America, really. And it would have weather predictions. It would have the days of it would have the lunar phases because you might not know this, but people were uh, uh, planting according to the moon, and that still happens. So they were in there too, in any astronomical events, and then sort of culturally relevant stories that appealed to rural America. But in that was where this mention of this blue moon being this fourth moon in one season. I don't know why blue, and I have researched and researched. I just don't know. And then, of course, as Paul mentioned, it was sort of misused in 1949 or something by someone in an article. An amateur astronomer used it to refer to the second moon in in a calendar month, and then it just sort of got picked up, and that's why we have blue moon. And so it's not, we have this phrase of once in a blue moon, and it's not as rare as perhaps we think. As we've discussed, it's like every 2.7 years we'll have a blue moon. So two moons in one calendar month, and we're going to talk about why that happens in a little bit. So it's not so rare after all, although obviously this year we have a double blue moon because February lost its moon to March because it was a shortened calendar month. And the next one, as Paul mentioned, the next blue moon won't be till 2020 on Halloween, which is kind of exciting. So that's sort of pretty simple about the blue moon, hopefully. But why is it the blue sap full moon? And there it is. Ah, just lovely. Well, what on earth has this beautiful moon got to do with sap? So, oh, so I mentioned the Old Farmer's Almanac earlier, and the Old Farmer's Almanac keeps the names of the moons from the Native American peoples. That's where it takes the names of the moons. And the Old Farmer's Almanac was set up in the northeast of the US. So it took the names of the moons that were used by Native American peoples in the northeast. And as a collective, they were called the Algonquin peoples, but there were many individual tribes within the Algonquins, not to be confused with the Algonquian, who was sort of up into Canada. Um, and they called this, well, let's just step back a bit. So instead of, we just have calendar months, so this is like end of March, full moon, um, they called the names of the moon, they called the moons, that was their calendar, by what they saw around them. Um, and when this particular moon occurs, there was a cycle and it kind of helped them. So last month's moon would have been the snow moon. Actually, it was March the 1st, the snow moon, because they saw snow on the ground. And then with the coming of this moon, they knew it was time to go and tap the trees to get maple syrup. And the next moon would be called by some the budding trees moon. And if you've ever tapped for maple syrup, you know that once the trees bud, then the maple syrup's no good. So this was the moon where the trees released their sap that you could go and tap for maple syrup. And that is how it's got its name. But it also has a couple of other names. And because we've had two moons in March, we've sort of we're using the word sap, the name sap moon this month instead of using the typical name we use for a March full moon, which was the worm moon. So this moon was also called the worm moon because it was the end of winter. The earthworms were coming up out of the ground, hence the name worm moon. And worms attracted robins. So this was also known as the robin moon. Also in the northeast, it was known as the crow's moon, the full crow moon, because as winter was passing, the crows would start to make a lot of noise. I always think of this as sometimes the grackle moon, because I don't know if you have grackles where you live, but they make a hell of a noise around this time of year. So that's kind of and what the names were helpful for was sort of remembering what was coming so you could prepare. So, for example, if you were a place with your peoples where there weren't any maple trees, then if you knew that the sap moon was your next moon, you could gather your people and move towards where you would find maple trees. Similarly, if you knew the snow moon was coming, then you knew maybe you had to hunker down with food or get some more warm clothes. So it was always like a practical guide, and each moon also came with its own rituals because it was felt like each moon carried an energy. So really, really beautiful. Um, but a couple of nuances around geography and the lunar calendar that actually mean this moon may not be a sap moon at all. So let's talk about geography first. And I was keeping a track on Facebook, and so I see there's people from really all over the US, some people from Brazil, up in Canada. So you'll understand this, hopefully, but between us, maybe we can all put some comments in Facebook in a moment to what I'm about to say. So I am in New York, and I'm in real southern New York because I'm in New York City. So for me, this isn't really a sap moon. In fact, my friends who are mad on tapping for maple syrup um, did that 3 weeks ago, not far from where I live, like a couple of hours drive north. So the sap moon would have passed. For me, this is really more like the budding trees moon because there's buds have been on the trees a couple of weeks now, and even some flowers are starting to occur. And I was seeing robins maybe 4 weeks back as well. So if you're in Vermont, however, this could well, like northern Vermont, this could well still be your sap moon. So it's not the same for everyone. So I want to give you some examples of other moons as around the country. So if you're in the Pacific Northwest, this would actually be the budding moon of shrubs and trees. It's a more temperate climate in the Northeast. So that makes sense. In New Mexico, for the Pueblo people, it's the moon where the leaves break forth. So much earlier spring is happening down in New Mexico. I love this one in talking about sort of practical names. The moon where the wife had to crack bones for marrow fat. That's the Lakota peoples for this time of year. And also the moon of the sore eyes because of the snow blindness. So we're a little bit behind that, I think. Alaska, migratory geese moon. We talked, you might have heard Dr. Paige Godfrey talking about the strawberry moon. Yep, the strawberry moon from the Old Farmer's Almanac is in June, but it's actually now for the Cherokee down in the Carolinas. And I've not been down there at this time of the year, so I don't know. But I gather that you can actually pick strawberries now in South Carolina. So this is sometimes called strawberry moon down there. And the Great Lakes actually don't get the strawberry moon for quite some time still. And uh, and the Dakotas even later. So just really different names to think about, even though we're just calling this a sap moon. And it's not just North America that where native peoples named moons. So in Siberia, for example, the culture was really attached or built around reindeer. So this moon, to some peoples in Siberia, is known as the moon of the full udders, and it precedes the next full moon, which would be the moon of the uh, newborn reindeer calves. So at the moment in Siberia, the reindeer is sort of the mama reindeers are getting ready to birth. So they're getting full udders. That's what it's called there. There's some really wonderful Celtic names. This particular moon is the moon of the winds. Um, and then sort of from Europe and sort of the pagan cultures that were there and the Druids, we have names like Maiden Moon for this particular moon, the Hare Moon, Awakening Moon, and the Planting Moon. So it's really kind of cool to kind of think about your region and really just have a think about what you would call this moon. Like it's going to be different for every single one of us. So I'm sorry, I'm just checking back in case I had a question from the studio. So, you know, the other thing to point out is that moon cycles, while we're calling this the full sap moon, the moon cycles for peoples who go by lunar calendars start with a new moon. So we're already halfway into this particular moon, and we've only got another 2 weeks of it left. So the sap moon really started a couple of weeks ago, if you're going with that as a name. So yeah, if you're on social, I'd love to hear, what you're seeing in your region and maybe what you'd call it. And I know a couple of people from Brazil um, are with us on the show, and I had a look for South America, and I just couldn't find the names of any moons. But if you have any, I'd love to hear them. My research sort of hit a block there. One of the things, and this will help us maybe understand, is the blue moon is that what happens with these 12 moons that we have in a lunar calendar is that, as Paige and Paul pointed out, the whole lunar cycle is only 354 days long, which is 11 days shorter than our solar year. Which means that if you keep these moons going, at some point every year they're going to get shorter and shorter, and they're going to move back and back and back. So you would end up with a sap moon in perhaps around February, because the solar moon is what dictates the seasons. The solar calendar rather dictates the seasons rather than the lunar calendar. So they kind of get out of sync. So what happened with people's Native American peoples is that they would have a 13th moon. And some would keep the 13 moons going in rotation, and then every 2 3 years or 3 years they'd drop a moon to keep them back in line with the sort of the more typical solar calendar of the seasons. And for some, they would add an extra moon in every 2.5 3 years. That would be an extra one added in. For the Druidesses, and it was sort of seen the connection with the moon was more a feminine one. The female Druidesses and priestesses would actually determine which moon they were going to add in. So if they had a very good harvest, you would just add in another harvest moon to that cycle for the whole seasons together. But it's so hard to get your head around because we think so rigidly in terms of the Gregorian calendar in January, February, March. So it sort of threw people off this month because we had these two moons in March, that people were saying, well, the March 1st should be the worm moon, and this should be the worm moon too. But this is like the whole point, that every now and again you kind of have to add in an extra moon because there are only a certain number of moons that go through the whole of our solar calendar cycle of seasons. And it's because of this confusion actually that we have ended up with the Gregorian calendar that we have today, because of these 12 months of the 12 months being sort of longer than the 12 moons, as it were. Because you might not know this, but another name for our moon today is the Pascal moon. And Pascal is from Pascal is from Pascha, which is from Passover. So the lunar calendar, while we may not sort of think about it, is really sort of impacting and having an influence on our cultures to date, because this weekend is when Passover begins. It's a Jewish holiday, and the Jewish calendar is quite similar in that it keeps these 12 moons. The new year begins in September, and Passover is the 14th day of the 7 month. And it will always sort of coincide with a full moon. And because of these 12 moons, an extra moon has to be added every 2 years or so, which pushes Passover back sometimes to be the second full moon after the spring equinox. And I mention this because Easter is also this weekend, and you might not know this, but Easter was timed with Passover. But because of this extra month that was added in the Hebrew calendar, what happened was the Christians decided to be much more rigid with the calendar and not adhere to the lunar calendar. But then, of course, we had the Gregorian calendar from Pope Gregory the 13th. What they did was said Easter falls on the Sunday after the full moon, after the spring equinox. So we've had the spring equinox. Today is the full moon, and here it is rising in the Canary Islands right now. And tomorrow will be therefore Easter Sunday, so which is sometimes why Easter and Passover coincide, like today, and sometimes there's like a month difference. And it's not just, talking to world religions. Islam, for example, keeps very rigidly to the 12 moons. So its holidays do actually move through the seasons as it sort of falls out of sync with our solar calendar. And Buddhists also are very tied to the lunar calendar for new moons and full moons. And in Hinduism as well, there's a sort of celebration around the new moons and full moons, but it also has its own calendar going on. So a lot really to consider, a lot of information coming at you today. I can feel it. But a lot to sort of really sort of ponder and reflect upon when a full moon arises, like, how as people's we used to very much depend on just using our judgment with the moons and letting the moon guide us and keep time, and how that's sort of been kept over time, but also how it's changed slightly. And I always think that full moon is like a really wonderful time to sort of get in touch with nature, because you can get out there for one and have a look up and you're outside, but also reflect upon, like, what would you call this moon? What would this moon be named for you? And I thought it'd be fun to ask Paige and Paul what they would call this moon. So I wonder if we can invite them back. And they are. So who's first? What would you call? Well, I'm going to go with you, Paul. I don't know. What would you call this moon, Paul?
Very unimaginatively, it would have to be the chocolate moon. But that's only because I'm a chocoholic and it's Easter tomorrow and I'm looking forward to my Easter egg. So the only other one I would do is Last Logs Moon. And I don't have central heating here. So the only source of heating we have is log stoves. And I've just taken delivery of the last load of logs, the last ton of logs that have to be manhandled into the house. So I think that would be my end of March moon, my last logs moon.
I love that. Hello. What about you, Paige?
Can't hear you, Paige.
Can't hear you, Paige.
While we're getting
Sorry,
Paige's audio
y'all.
in.
Now you can
Oh
hear
no,
me.
you're back. Yay. You're back.
I
Hi.
totally had myself muted to help when I was offline. And then here I am. So yeah, I've been thinking about this for a while, and I'm gonna call it. I'm gonna be nice and call it the spring moon. But what I really want to call it is where is spring moon? Because here in New Jersey, it's actually decent today, but all around today it's cold, and it's the end of March. It's April tomorrow, and I want to know where spring is. So if this moon doesn't bring me spring, I'm just not happy.
I like it.
I call this
The
I call
where is
this moon.
spring. Go
Yeah,
on.
I'm all right with it not being spring, because I call this moon time to get to the gym moon. If I know spring is coming and the body has to come out, it's time to get to the gym moon.
So it's not because of all of the chocolate at Easter,
No,
or is that a
no, I'm not
contributing
even
factor?
allowed chocolate Easter. We've had the moon, which means it's time. Time for it. Serious.
Oh, that's great. By
Yeah.
the way, Helen, I'm sure you made up an animal during your segment. I don't believe there's an animal called a grackle. Is that what you called it?
Yeah, it's a bird.
Is it? A
Yeah.
grackle? Well, I think it's got to be a grackle moon, hasn't it? That's just such a fabulous word. It's the
Yeah.
grackle moon. So anyway,
We
listen,
don't
we've got
have in
some.
England. Don't have in England.
We don't. We don't.
No.
So not that I've heard of anyway. Noisy birds don't have them here. We've got some questions coming in on social. And Paige, we've got one here from Jose Enrique de Jesus, and he's asking us what is causing the tilting of our planets, including the sun. So is this a axial tilt? We were saying that Earth is 23.5
Yes.
something. So what's the answer for
Yes.
Jose Enrique?
So there's two different answers here for the planets and then for the sun. The Earth is tilted, which is fortunate for us because it gives us our perfect seasons, which is what has allowed life to flourish. But that is because of the way the solar system formed. When all of the planetesimals were forming and crashing into each other, they just kind of forced tilts of rotation. So we're actually rotating on this tilt, this 23.5 degree tilt. The sun, on the other hand, is a really interesting story. We've known about the sun's tilt for a long time. It's a 6 degree tilt with respect to us, but we actually really don't know why. One of the latest explanations is the elusive planet Nine.
Mm.
So, when the solar system formed, and this is common to solar systems in general, the gas nebula, the cloud of gas and dust that forms the solar system flattens out into a disk. And so all of the planets are orbiting. Oh, look, there's a nebula.
Crab
That was
nebula.
perfect. Studio, thank you. So the planets are all orbiting around the sun in a plane. And this is just a consequence of the gas cloud collapsing. But the sun is tilted with 6 degrees respective to the plane. And actually, what we think is going on is that the sun is not tilted. The plane that we are rotating on is tilted because of
Mm.
Planet Nine's gravitational effect. So, Planet Nine, which is on an inclined orbit, so it is not, if it exists, it is not orbiting in the same plane that all the other planets are. It's like maybe going like this instead of like this. And
Okay.
when it comes through, it actually tilted our plane.
Uh-huh.
So
Okay.
it's just a theory because we haven't found
Wow.
Planet Nine, right? But it's really interesting.
There are
Yeah.
so many, big unknowns like this, aren't there? I mean, and the
Yeah.
real oddball when it comes to planetary tilt is, of course, Uranus. The planet Uranus is actually on 90 degrees tilt. I mean, the whole planet has been tipped on its side, which is,
Mm-hmm.
there's, but I kind of love that about astronomy. We've still got these things right on our doorstep. And as you say, Paige, we still don't know the
Yeah.
answers. I kind of love that.
Well, here's a question for you, Paul. Another one from
Okay.
Facebook from Jamie Dale asking if the atmosphere creates the color of the moon and sunsets, etc. What causes the green flash that we see at sunset?
Ooh, now this is the
Ooh.
elusive green flash. Now, I spent 2 decades waiting to see this, and it was one of my trips to the Canary Islands Observatory, where our telescopes are based, that we're watching tonight. And we're at high altitude there, at 8,000 feet high up, and we see sunset and sunrise directly over the ocean. So you see it right,
Mm.
as far down as it can be through the maximum amount of atmosphere. And one night, I saw it one evening. And in fact, Helen, we were doing a show. We were doing a sun salutation show. It was that very evening.
Oh.
And
That's
what,
awesome.
what this is, it's the very last bit of sunlight, which is dipping below the horizon, is being refracted by our atmosphere. And that's the last bit of light that reaches our eyes. And of course, it's green light. We've already said that red light gets refracted really quite easily, the blue light next, and it's the green light, which is the last light, which is affected by that. So that's when we just see this little green flash. And when you see it, it's unmistakable. I've often
Mm.
seen it more as a kind of yellowy green, but it is absolutely momentary. But it's exactly the same cause as all of these other effects that we've been talking about tonight.
Is
So
there
yeah.
is there somewhere like is there a way to go and see it? I mean, you look for 2 decades. Is it like you need to be on an ocean, you need to be a certain place? Because it sounds amazing.
You need a clear horizon. I mean, that's the main thing. And if you can get to, a clear western horizon, over water, then even better. I mean, you can, in theory, see it in the morning as well, but it's more difficult to time it then because you're waiting for the sun to appear. But it's
Mm.
it's easier to see this green flash right at the end of sunset with a clear horizon. So you are seeing through as much of the atmosphere as you possibly can. It's probably the one celestial event where actually you want to look through more atmosphere than less. So, but
Mm.
there's
Wow.
this other atmospheric illusion as well. Well, we thought it was atmospheric, didn't we? And this is this moon illusion. And Paige, have you seen this? Is this something that you've kind of recognized and seen and thought to yourself, "Whoa, what's going on there?" Or Helen,
Yes, and I
have you
get
noticed?
my friends will text me, "Go
Mm.
outside and look at the moon. It's huge."
Yeah.
Exactly, it's bigger. And there was a survey done, and they asked for people's estimates. They got people to look at the moon when it was on the horizon, and then look at the moon later on at night in the sky when they couldn't see anything in the context. And they asked them how much bigger was the moon when it was on the horizon, and they said between 50 and 75% bigger. All right. So this is a huge effect. This is not just something, fairly minor. This is people truly believing that the moon is bigger on the horizon. And I was looking up some of this on some of the possible theories, and it's like so much in astronomy and life in general, I guess. There was this one piece of information that came out that said it's all about the atmosphere magnifying the view. And of
Wow.
course, as soon as something like that is said, and is widely published, bang, everybody grabs hold of it. And but there
Yeah.
is no magnifying effect. There's a very
Right.
big distorting effect when we watched the moon tonight rising on the horizon. It was almost flat. It was kind of all squashed down because of the way the light is refracted in the atmosphere. But once again, it's one of these effects that psychologists have some ideas about the causes of it, but we still don't fully understand it. It's a bit like those other optical illusions. I think there's one called the Ponzo illusion, and you've probably seen them. They're all these little diagrams where you see railway lines going off into the distance, and they put
Mm.
a line
Yeah.
there, and they put a line here, or a circle here, and a circle here. They're always the same size things, but one of them
Mhm.
always looks so much bigger. So it's really about the context. And so if viewers haven't seen this themselves, now with a full moon over the next couple of nights is a great time to do it. Go out shortly after sunset, have a look at the moon as it rises in the east, and kind of see how big it is. And actually, a good way of doing this as well is to hold your thumb out at arm's length, and you'll probably find that your fingernail covers the moon almost perfectly. But then look at it a couple of hours later when it's risen off the horizon, and see whether it looks bigger or smaller. Then hold your thumb out again, and you'll actually see that it's an identical size. But I bet you, a lot of our viewers will think, "Whoa, it was so much bigger down on the
Yeah.
horizon." So
Yeah. It does look bigger. It does. I mean, I
Yeah.
think so.
now, what else are we
So
going to cover?
there's
We're looking. Go on, Paige.
Oh, no, I was just gonna say there's something else that we should be looking up for this weekend, right?
Oh, there
Do
is
you want to
big,
tell us
big
about that
story,
some?
isn't it? This
Yeah.
is a heavenly palace, which is actually going to be turned into a fiery tomb, I think.
Oh my
Now, this is oh, come on, Helen, give me a little bit of
God.
jour- journalistic freedom here. I mean, it's called the Heavenly Palace. It's called Heavenly Palace One. It's actually the Tiangong One space station. Now, this was the prototype, the Chinese prototype space station that they launched in 2011. But they lost control of it in 2016. Now, they didn't admit they'd lost control of it for quite some time. And in fact, I still think they're not fully kind of saying we've lost control of it. They're just saying if it's going to hit
It's
anywhere,
gonna
we'll
crash.
alert them. We'll alert them kind of 5 minutes before. But anyway, this thing is 8.5 tons, 8.5 metric tons. It's the size of a bus, a coach, and ever since they lost control of it in 2016, it's basically been getting lower and lower in orbit. And the latest predictions are that this huge piece of space junk is going to enter the atmosphere uh, probably Sunday evening, which is UTC. So around 4:30 Eastern time. And this is plus or minus 8 hours. We still don't know exactly when. So this is 2030 UTC. So it could happen tomorrow evening. So we might even see it in our low light cameras in the Canary Islands or the Chile Observatory. Um, but the reason why we can't time it and we don't know where it's going to come down. In fact, this is a great diagram. There's a map of the world. What we know is that this huge piece of space junk is going to hit somewhere in the green zone. Outside chance it could be in those yellow bands, but it's going to be. So this is it. I mean, this is the extraordinary part of this story is how on earth we can have this enormous chunk of stuff up there and be so totally out of control with it that we don't know when it's going to enter the atmosphere. But part of the reason why we don't know when or exactly where is because of Earth's atmosphere. Now, today we were watching a lot of solar activity. Now, solar activity sends a whole stack of charged particles and high energy particles from the sun into our atmosphere. And what it can do is it can heat our atmosphere, and it actually makes the upper atmosphere expand and contract slightly. We can't forecast that very well. So as this space station is actually dropping in orbit, and at the moment we've seen some great radar images of it, and it's spinning on its axis with its two enormous solar panels on either side of it. It's spinning really, really fast. We don't know how thick the atmosphere is going to be at any one point before it really starts to take hold of this thing. So what it's really going to do is the first thing that's going to happen is those two solar panels are going to be ripped to pieces. They're just going to be shredded off the entire thing. But then as it enters the atmosphere about 50 miles up, it's going to be going so fast, it's kind of bullet fast. It's going to be vaporized, or at least we hope it's going to be vaporized, right? We do think that there's a very good chance that there are going to be parts of this that do reach the atmosphere. So, we're going to be keeping an eye open for this. We don't know when, we don't know where, but if you go to the Slooh website, if you go into the left-hand navigation, and if you go to illuminations, then you'll see a post in there that I did today, which gives you a link to a couple of websites. And if you pop your own location in there, it will tell you whether or not the heavenly palace is going to be passing overhead. And if it just makes a pass over your head before it even comes down, you should be able to see it with the naked eye. So there's a couple of links
Oh.
to those websites in that illumination post. And in fact, you guys on the east coast of America, you actually stand a pretty good chance of seeing this if it's on the later part of the time scale. So 4:30
As long
is
as we
the
see it way up there
Yeah,
and not anywhere
going past
near the
you.
roof of my
Okay.
house,
yeah.
then cool.
Get
Okay.
your helmets. Put your helmet on,
Well,
Paige.
although this is, a bus-sized piece of space junk coming down, would you believe that this is only the 50th largest piece of space junk ever to hit the atmosphere? So
Once
it's
in a blue moon,
it's
some people might say.
exactly, but
Hey.
this is quite a small chunk. There's one of the main websites that we're pointing people to, and this has, updated information on exactly when this thing's, well, not exactly, but it's going to get our prediction of it is going to get far more accurate as we get closer and closer to it. But certainly one to keep an eye open for in our all sky cameras in the Canary Islands and at the Chile Observatory. So,
This is making me think of the Humanity Star, which
oh
was
yeah,
that space station that was sent up to encourage people to look up, which was supposed to stay up for 9 months until around October. and it has already burned up in the atmosphere.
Oh, I
So,
didn't hear that. Wow, I
yeah, I
didn't
just
hear that.
read that today. Yep,
This
it
is
was
this past, like,
deorbiting a lot faster. It was
wow.
hollow, and I guess the calculations, I don't want to say were wrong, but predicted it would stay up for 9 months. And because it was hollow, it deorbited a lot faster and it burned up. So,
Wow.
An
Well,
expensive
there was
experiment.
lots of artificial uproar about this thing, about it, illuminating the sky and stuff like that. It was only going to be as bright as the space station when the space station goes over, and
yeah.
what it was doing was it was kind of doing what part of our mission here at Slooh is as well. It's about kind of unifying the human race about this,
Mhm.
eternal awe and wonder about the night sky. So, for me, it was, if it got people outside looking up, good on it. We always knew it was not going to last very long, and it wasn't going to interrupt with astronomical observations or hit the Hubble Space Telescope or anything else. But anyway, listen, we should probably wrap up our Blue
Mm,
Sat Full Moon show, shouldn't we? But we've still got
probably.
plenty to look forward to this coming week. Paige,
Yeah.
what have you got coming up?
So this week is actually the last session in my Intro to Astro course. We
Ah,
are finished the syllabus. This is the last one, and I'm going to be talking about the dark universe, dark matter, dark energy, and how about 95% of what makes up the universe we can't see,
you
which
lost
is
it.
Love it.
fascinating.
Love it.
Very careless. Astronomers have lost 95% of the universe. Is that what you're telling?
Oh, we'll find it.
Helen, you've got constellation stories when? Tomorrow night or
No,
next?
sadly not tomorrow night because I am traveling. But next Sunday, we are celebrating spring. I promise you, Paige, it will be here. With a typical spring constellation that we all know and love, Ursa Major. So I'm really
Oh,
excited about that. Yeah, we'll be doing the Great Bear or the Plough or the Big Dipper or however you know it. We're going to take a look at the stars because one of those popular constellations. We all can name it. If you ask people to name two, they'll say Orion's Belt, which isn't a constellation, but they'll say and and Ursa Major. Who can name the stars in it? Barely anyone can name the stars that we see in it. So we'll be taking a look at those stars. Can you, Paul Cox? Can you,
I
Doctor
thought
Page
you were gonna
Godfrey?
I
Nope.
thought you were gonna be kind there and not ask us. I was thinking that, of course, we I think Mizar is one.
Hmm.
Is Mizar one? Yeah.
Yeah,
So I've
yeah.
done one. Paige, over to you. You can do the others. No, we won't do
So
that.
there's
But
Alpha Ursa
Oh,
Major, Beta Ursa
oh, you're
Major,
cheating.
oh,
Miser, and Alpha.
You're cheating.
cheating.
I mean, since you asked Paul first, I totally had time to Google it.
But we'll be looking at those, the Pinwheel Galaxy, there's the Owl Nebula, and we'll be sharing stories of how our ancients saw this constellation, how we got the name, and also how indigenous cultures and Aboriginal cultures saw this constellation. So that'd be pretty cool. Next Sunday, the 8th.
Okay.
Paul, do
Cool.
you
What about you,
have
Paul?
your practical astronomy this week?
I do indeed. Tomorrow evening, Sunday, 6 p.m. Eastern, which is 2200 hours UTC, and we are going to be creating galleries. So galleries are a piece in the Slooh members when they've snapped all their images from the live telescope feeds like we've had tonight. They all go over to a place called My Pictures, and we can create galleries. So we're going to be creating galleries to hold the huge number of images that we all snapped during the Messier Marathon a couple of weeks ago. So we're going to look at that, and a couple of members have asked me about when the right time is to snap their images during their missions. So that's going to be what we cover tonight, tomorrow night. So really, plenty to look forward to here, really. But that's it for our Blue Moon show, I guess, for tonight. Don't forget, if you enjoy what we do, Paige, you're going to have to come up with another course because I know that has been so popular. You've got to extend your curriculum, I'm afraid. But anyway, listen, if you do enjoy what we do, then please support us by joining our worldwide community as an apprentice or astronomer member, and you'll also get to control the telescopes that we've been watching tonight. So anyway, many thanks to Laura Grosso in the studio tonight. Thank you very much, Laura. Laura's joining us full time in a couple of months, so that's going to be absolutely brilliant. But also many thanks to you, Helen and Paige, for joining us tonight for this rare kind of double moon event. And for me, it's goodbye and I guess happy Easter.